We now move on to the last part of the data transformations and processing, and this is called text pre-processing. Now we are trying to use more and more text in our data processing and machine learning and predictive analytics. But text has a few characteristics. It has a lot of issues which a regular data set that comes from a table like an RDBMS table does not have. So text has to undergo a lot of pre-processing before we can start using them for predictive analytics. And in this section we are going to see what kind of processing needs to be done on text to convert it into a format that helps it to be used for predictive analytics. To begin with, let us try to understand how machine learning algorithms work. And machine learning algorithms can only work with numbers or continuous data or classes, discrete or categorical data. They do not work with text. They don't understand text in any format. So the challenge is that all textual data, they have to be converted to an equivalent numerical or class representation. Text data has to be converted into numerical or class-based representation before it can be used for any kind of machine learning. The use of text is becoming more and more in predictive analytics, and the text pre-processing, that's why it takes a lot of importance in what you want to do in this case. So why is text pre-processing becoming more important is that we do a lot of text-based classification. Like when emails are coming in, you want to classify them as spam or not a spam. That is text-based classification. You have a number of news articles in the web, and you want to take this news article and classify them based on which domain the news article belongs to, like politics or sports or economy or things like that. Now all this classification requires taking text data and then classifying text data, and to do that, that particular text data has to be converted into a form that these machine learning algorithms are comfortable with, and that is what we're going to see what kind of things you typically do there. To begin with, there are a number of text cleansing steps that you do as a pre-processing for any kind of textual data that comes in. So what are the various cleansing that you do? The first thing you do is you remove punctuation, all the punctuation marks in the text. Suppose it's a document, suppose it's an email. You take the entire email and remove all the punctuations in the email. Then you remove white spaces, paragraph spaces, or carriage return line feeds and stuff like that. You remove all the white space in there, extra white spaces. You just keep the white spaces enough to differentiate the words, and then you kick out everything else. You convert all the text to lowercase. So what you don't want to do is a given word can occur in many formats. Like the same word can be in uppercase, lowercase. The same. So in that case, you want to just look at which word occurs without bothering about whether it is uppercase or lowercase. So you kind of convert everything to lowercase. You typically remove numbers, the numbers like in terms of amounts of score or something like that. You remove numbers from text. You remove what is called stop words. What are stop words? Stop words are frequently occurring words that doesn't have a meaning in them itself. For example, is, and, they. All these commonly used words are called stop words, and they typically don't have any meaning, and they occur in all the documents. You're focused on words that occur unique in a document. You're not focused on these commonly occurring words like this, and, there, was, then. So you kick out all these stop words out of the document. Then you do what is called stemming. So what is stemming is that the same word has multiple forms in which it is used depending upon the grammatical requirements. Like you have a word called fast. Now fast can be used like fast, faster, fastest. You can have a word called real, so you can say real or really. So what you try to do was you only want the gist of the word, so you just keep the front portion of the word and you chop off the remaining portion. So fast, faster and fastest, all of them will become just fast. So that way you know it is the same word, it has the same meaning, it is just that you're removing the grammatical use based on the present tense and future tense and stuff like that. That is called stemming. And then you remove any other commonly used words. Suppose if you are analyzing emails coming into your company, typically all the emails will have your own company name. So you don't want that to be occurring and disturbing all your machine learning stuff. So you just want to kick those commonly used words also out. The difference between this and stop words is like a set of commonly occurring words used globally, and this is more like specific to your use case. That's the only difference. So you do all this text processing first, and then you do what is called as TF IDF, which we are going to see in the next slide. What is TF IDF? TF IDF is the most popular technique by which text is converted into table-based data. So text documents are becoming, as I talked about, more and more in machine learning. They are used for news items for classification, email messages for spam detection, and also textual based search. And a text needs to be represented in a different way. It has to be represented in terms of numbers and classes for machine learning algorithms to properly recognize and use them. So how do you do that is you use this technique called as term frequency inverse document frequency. It's called TF IDF, term frequency inverse document frequency. And what this technique does for you is that it converts text into a table, and the table basically contains rows and columns. So every document becomes a row and every word becomes a column. So every document becomes a row and every word becomes a column. So what do you mean by a document here? Document doesn't mean it's necessarily a Word document. Any piece of text is called a document in text processing sense. Any piece of text, it may be just a sentence, it may be just a tweet, it may be a text SMS message, it may be an email message, it may be an entire news article. All of them are called documents in text processing parlance. So every document becomes a row, and every word that occurs in any of these documents becomes a column. And then what happens is each cell represents a value, which is basically the strength of that word in the document. So if a given word occurs more number of times in a specific document, the value in the cell is a lot higher. If it is not occurring in the document at all, of course it is going to be 0. So the strength is represented in each of the cells. So what you see is that it becomes a table very similar to a normal data table, where the rows represent the documents and the column represent the words. And obviously the number of columns you are going to be having is a lot of columns, and it is only to eliminate the number of columns that you have or reduce the number of columns you have. You do all those pre-processing, like removing the commonly used words, and then you do stemming, and then you also remove the other stuff there. So you're trying to reduce the data set by doing those techniques. So how does this TF IDF work? We start off with what are the formula for use for TF IDF. And first, what is the formula for text frequency? Text frequency is computed for every word for every document. So given a word and given a document, text frequency of that word in that document, text frequency of that word in that document is equal to the number of times the word occurs in the document divided by the total number of words in the document. The number of times the word occurs in that document divided by the total number of words in the document. This is pretty simple and straightforward. It just tells you how many times a word occurs. So the more number of times a word occurs in a document, the higher is going to be this value. So it just indicates the strength of that word in the document. Next comes inverse document frequency. Inverse document frequency gives you a measure of how unique that particular word is how unique that particular word is, basically where it only occurs in a few documents and not in all the documents. So inverse document frequency is computed for a word across all documents. It is not done document by document. It is done across all documents. And the way it is done is you do a log E of total number of documents divided by the total number of documents where this word exists. So inverse document frequency is for a given word, which is equal to the log E of the total number of docs divided by the total number of docs with this word. So what happens when you compute inverse document frequency is the lesser number of docs this word occurs, the higher will be the inverse document frequency. That's how this formula would work. If a word is occurring in all documents, inverse document frequency will be like 0. If a word occurs in only like one document, inverse document frequency will be really high. It tries to find the uniqueness of a word in a document, and TF IDF is nothing but you multiply the text frequency with the inverse document frequency. So that is the final formula you're going to get into. So what we're going to now do is we're trying to take a set of documents and we're just going to do all these things we talked about as an example use case. So let us start with a set of original documents. So these are the 3 documents. I just made these words up or the sentences up, so don't worry about a lot about these sentences. Imagine these could be like emails, or this could be chats or SMS, whatever. You have 3 documents here. This is a sampling of good words. He said again and again the same word after word. Words can really hurt. And the first thing you do is you do all the cleansing that we talked about before. And after you do the cleansing, this is the kind of output you get. So what you see here is words like this, is, and so the document, this is a sampling of good words, has become sample good word. You see what has all been kicked out. This is an A or gone. Sampling has become sample. That is because you do stemming. Off is gone. Good is retained. Words have become word. That again is stemming. Because you took out all these singular, plural, past, present tense, future, and just focused just on the core word. So this is how it becomes. So this is how the 3 documents, document 1, document 2, and document 3 ends up after you do all the cleansing that we talked about. Then we build what is called as a document term matrix. This is called a document term matrix, in which the documents are the rows and the terms or the words are the columns. So this is called a document term matrix. So the words are actually columns here and the documents are rows. The first thing you do is you try to create a count table. The count table, what you're doing is you just count the number of times each word occurs in the document, and this is how the words occur. Then you try to find text frequency, which is you take this count and divide by the total number of words in the document. So in document 1 there are 3 words, sample occurs 1, so it is 1 divided by 3, it becomes 0.33, and you do the same formula for all the 3 documents for all the words, and you end up with this term frequency table. Once you have the term frequency table, the next thing you do is you compute inverse document frequency using this formula log E of total documents divided by the documents with the word. And when you do this, inverse document frequency is computed across all documents for each word. So this is the value end up with for inverse document frequency for each of the words when you apply this formula. Then it is easy for you to now compute TF IDF, which is you take the same term frequency table and multiply that by the inverse document frequency, and you end up with the table below. Now what you see interesting, you see that the word occurs in all the 3 documents, and it ends up as having a score of 0, because we are not bothered about words that occur in all the documents, because that does not give us any form of differentiation. Rather, we are focused about unique words that only occur in one class and not in the other. So a word like again, it occurs only in one document, document 2, and it occurs multiple times in the document, so it gets a pretty high score. The analogy is that when you want to differentiate documents, you go after the unique words in the document, and this is how you found the unique words and score them. So this is the final table you end up with, where documents are in rows and the words are in columns, and the score indicates how good or unique that particular word is. And this document then can serve as an input. This becomes like a regular table, data table, and this can be used as an input to any of your predictive analytics machine learning algorithms, very similar to the other data. There is no difference in text handling versus non-text handling in this case, because all you're dealing here are with numbers. So this is how you process text, and you will see some examples in the use cases that follows. I hope this has been helpful to you. Thank you.